One of the larger problems with structural simulations of fiber-reinforced plastic parts is determining the material orientations which should be used for the analysis. Traditional analyses assume that the material is randomly aligned everywhere, which leads to near isotropic behavior of the material. Autodesk simulation composite analysis can bridge the gap between manufacturing simulation and structural simulation by mapping material properties and fiber orientations from an Autodesk mold flow simulation to an Abacus structural simulation using the advanced material exchange. In reality, fiber orientations are not perfectly random and can vary widely depending on the manufacturing method, such as gate locations. The impact on the structural analysis is twofold. One, fiber alignment causes orthotropic behavior of the material, which in turn changes the stiffness of the structure. Two, fiber alignment can cause weak areas of the structure where two flow fronts meet, which are known as weld lines. Using as-manufactured properties within the structural simulation can only increase the accuracy of the structural simulation and help to identify potential areas of concern before the part is manufactured. Structural simulations have different requirements than those of the manufacturing simulation. Therefore, most structural models are oriented differently than those used for the manufacturing simulations and have a different mesh. The Advanced Material Exchange is a utility which comes prepackaged with Autodesk Simulation Composite Analysis. Its purpose is to translate data from a mold flow simulation to the structural mesh and set up the structural model for nonlinear analysis. Advanced Material Exchange can automatically align the models which do not share the same global position, as well as allow the user to interactively align models through a series of rotations and translations. Once aligned, Advanced Material Exchange also supplies the ability to check the structural mesh and identify areas in which the mapped data may not be as accurate as desired, which allows for mesh refinement prior to running any structural simulation. This can save valuable time and unnecessary runs. After mapping the data, fiber orientations are displayed on both meshes. The data is interpolated using nodal positions and element shape functions from the mold flow mesh to the structural mesh, ensuring accurate data transfer between models. Finally, all material data associated with the mold flow model is automatically taken in to the structural model. Additional material data for elastic plastic failure simulations are entered by the user in the form of stress-strain curves to failure, both in the flow and cross-flow directions. Most material suppliers can provide the required data, or Autodesk can recommend a testing partner to calibrate the data for use with Autodesk Simulation Composite Analysis. Advanced Material Exchange will output a new input file for the structural analysis, which will require the use of Autodesk Simulation Composite Analysis to generate fiber orientations and predict material nonlinearity and failure. The robust convergence technology embedded within Autodesk Simulation Composite Analysis allows users to simulate material nonlinearity and identify failure for an as-manufactured structure for both thermal and mechanical loadings.